Hello, everyone. Uh, Good morning, good afternoon, good evening, from wherever you are joining with. And thanks for joining. So we'll start today's webinar on using buildings AI for heating and cooling load calculations and HVAC equipment sizing. So introducing today's speakers, myself, Praveen. I'm the product marketing manager at Simulation Hub. So I'm basically a mechanical engineer with over 15 plus years of experience in this field and more strong on the CFD side and as well as the HVAC load calculations and building performance analysis. So with me joining is Swapnil. Swapnil, please introduce yourself.
Yeah, hello everyone. Greetings of the day. Thank you for joining and greatly appreciate your interest in our product. So I am Swapnil Dindorkar. I head the Buildings AI product unit here, and I come mainly from engineering simulation background, having experience from right from applying simulations to building environment, CFD analysis, electronic cooling type of analysis, and now I'm looking over the whole building performance type of applications. So I enjoy this particular role, speaking with customers, basically solving their problems and how to convert their particular problem and apply our products to solve their business needs as well as their application needs in the whole building performance analysis. So I think Praveen will continue for the next few slides. Thank you.
Thanks, Swapnil, for that introduction. So we'll start with the agenda. So what we are going to see or discuss in this webinar today is we'll start with the fundamentals. There is a mixed set of audience. Some might have more experience in this field. Some might be starting at the initial stage of their career. So I thought it'll be a good idea to start with the fundamentals and then move on to more advanced topics like about the software, about the product, what value it can add to the process and such things. So then we'll see what are the key features of the product. We'll introduce Buildings AI and the features, and we'll go to the product demo. And there is a short case study which we have done with the software. So Swapnil will walk through the demo on the case study, and at the end we'll have the detailed Q&A sessions. So meanwhile, if you have any questions, feel free to post them on the chat. We'll be collecting them and answering them at the end of the session. So that's fine. So yeah, next we'll start with what is cooling and heating load. So it is the rate at which we remove or add the heat, the rate at which the heat must be added or removed into a space if with the aim to maintain certain desired condition in the space. So here we are talking about, when we say condition, we are talking about temperature, humidity mainly. So how do we do that? There are different load components, that contributes to the space cooling and heating load. So I have combined both cooling and heating loads. Okay. So the components include the conduction of heat through roof, exterior walls and windows and skylights. And the second component is solar radiation that enters the space through windows and skylights. The next one is conduction through the adjacent spaces or interior partition walls, ceilings, and floors. So the next one is the infiltration that enters through the doors, windows, or small cracks in the building envelope. And the next component is internal heat gain. That is the people, the machines, or the appliances, lightings. So those also add the heat gain, into the space. The next one is so far we have discussed goes into the space load kind of thing, and then on top of that, the coil gets to has to address the ventilation load as well. This is something we bring in intentionally to satisfy the fresh air, to keep the fresh air flowing in the space. And there are additionally system generated loads, so which like for example, fans also add additional heat into the space. So this is it. And some part of the components highlighted in the blue has a latent part as well. So far, like sensible and latent heat. So which has, for example, infiltration air. It has both the humidity part of it, like, the latent part, and the internal heat gain. People and some equipments can add humid air or like latent heat into the space. And of course, the ventilation. So these three are the things. So now when we talk about heating load, so there are certain components that we do not consider in order to calculate the peak heating load. So because that gives us more, that adds and that helps in heating. So we do not want to consider that. So for peak heating load, we consider the conduction from the external and the internal partitions, infiltration and ventilation. So that's it. It sounds very simple, right? So you have certain load components, you calculate using MCP delta T formulas, and then you just sum it up and you get the cooling load and peak load, right? Well, it's not like that. So you have these many combinations of heat transfer mechanism going on in every second throughout the year and dynamically changing according to your site location and building orientation. So all sort of things going on. So it's not as simple as it looks. And adding to that complexity, there is the nature of the building envelope, like roofs and external walls, has the property to store the energy. It has the capacity to store the heat energy and then release it to the space with a delay factor. So that is time lag. So this adds on to the complexity. So how do we calculate these cooling and heating load? What are the different methods available? So there are wide range of methods available to calculate the cooling and heating loads, and they are quite simple to complex. It ranges from simple to complex, and it comes with the accuracy part. So the simplest one is instantaneous calculation UA delta T, but that doesn't captures the time lag factor. So then got introduced the CLTD, cooling load temperature difference and CLF methods. So this takes care of, this has approximated or based on the experiments, it has populated the data of time lag. So it accounts for instead of delta T, you substitute CLTD from those data table. So again, this has certain compromise on the accuracy. So these two methods, we can do it with the help of Excel sheets probably. But as we go on increasing the complexity further or more accurate solutions, radiant time series, transfer function method, or heat balance, which is most accurate method in the practice. So there you need the help of computer programs to handle such complex things. But you get the more accurate solution or more accurate the value of load calculation. But why do why do you want calculate the cooling and heating load very accurately? So what benefit you get, why it matters, right? So the right HVAC equipment sizing impacts two things. One is the thermal comfort, which is the core purpose of HVAC HVAC equipments, and the other one is energy consumption. And both of this has to be balanced and addressed. Without compromising the thermal comfort, we need to optimize the energy consumption. Why? Because US Energy Information Administration survey says almost 48% of the total building energy consumption is from HVAC equipments. So it goes into space heating, cooling, and ventilation. So depending on the zone, the heating might be more and cooling might be more, ventilation could be there. So, but overall, almost this is the almost half, like 50% of the total building energy consumption is from HVAC. So it really matters to choose the right equipment size. So along with the energy consumption, it comes the carbon emission and other parts. So we need to be really responsible and in choosing the HVAC equipment size in order to balance the thermal comfort as well as energy consumption. So there are a lot of software in the market, available in the market, which does this cooling and heating load calculation. So what is our motivation? Why one more software? Why we want to build one more, load calculation software? So what we understood is we interacted with a lot of MEP engineers and HVAC consultants. What we identified is, despite having so many softwares in the market, there are unresolved, unaddressed pain points still exist, which reduces their productivity on one side, and some forced to compromise on the accuracy part. So a lot of pain points. A few I have listed out here. So every time, although they have the model ready, they have to start from scratch in the energy modeling software they are using, because it needs a lot of gaps that needs to be fixed. So it needs a watertight analytical surfaces that it's a perfect error-free building energy model is required in order to apply the heat balance method and calculate the things. So this consumes almost 60 to 70% of the total process time. The second one is manual entry of large amount of data. It's all about data actually. So I have a slide which will give you the picture of what are all the data that is required, and how do you easily maintain. And the third part is, in this process there are a lot of stakeholders in this MEP, the project, like load calculation and energy modeling, energy analysis. So it starts from architects who gives the inputs, and then there is a MEP engineer who collects those input data and feed that data into the software in the right manner. And then he processes the things, and then the next step could be like taken by the energy modeler, then engineer. So a lot of things, a lot of collaboration goes into the efforts, like in the process. So this, and there are some challenges even in handling large building models in some software. Can you hear me? I guess, am I audible? Please confirm in the chat. So can I just... Yes, I see a lot of yes. Thanks for the confirmation. Okay. So let me continue with this. So this and many other pain points motivated us with an aim to address these things and make the process more productive and more accurate, fast. So we developed Buildings AI. So what is Buildings AI? It's an agentic AI platform for building load calculation and energy modeling. So it is powered by Energy Plus, the Department of Energy developed engine for energy simulations and load calculations. And we leverage Autodesk platform services for data management and visualization, viewer, and so that sort of things. And AWS, Amazon Web Services, because we run the simulations or load calculations on the cloud. So this is completely a web application. So that runs on the cloud. So there is no installation or anything. It's a browser-based thing. Like you just open, log in, and directly start working on the project. So what is the workflow? How it starts? This is where I said there is a data slide, right? So yeah, we'll see. So first, there are few sets of data that is needed, like site location, weather data, and the building type. Whether it's a school, hospital, or office. So those kind of building function, and which year or standard that applicable to your climate zone, or which compliance you're targeting. So those kind of inputs. And then it opens up another stage where the real building model is fed, and then the material construction assembly, and you assign zones, grouping of spaces based on the thermal zoning, and then schedules. So what is the occupancy schedule for the whole year, or the design day, and then the lightings, power, infiltration, ventilation, and set point. So these schedules are required. And so these things can also be based on, if you're running for the baseline simulation or something, then you can go for, based on the site location and building type, the schedules and material, default materials, all those things are selected automatically. But that's for the energy simulation most. And then moving to the next part, which is the HVAC data. So it needs air system settings data, and then the plant data. So once these data are rightly fed, then you get the energy analysis insights as well as the load calculation report. Okay. So what are the key features that we have developed so that it addresses all the other pain points we saw in the previous slides, right? So one very interesting key features where we leveraged AI as well to agentic AI workflows to address a very key problem in the process. So which is we are able to convert the AutoCAD architectural drawings to a detailed building energy model in a few clicks. So it's automated and intelligently done. So that is one main feature of this the platform, Buildings AI. And the data hub, where it's a centralized data storage and where people can collaborate. There are version controls to the project, and it helps, it facilitates streamlined collaboration between different stakeholders of the project. And load and energy calculation is of course there. And at the end, there is report GPT. It's a conversational LLM model developed to help you, assist you with creating the load report, customizable load and energy reports. It doesn't throw you hell lot of data on the face, so you can customize or do which data to be shared to be present in the final report. Okay. So it's completely AI powered data insights, and I can do submittals for code compliance and those things. So with this, I'll introduce a few other key AI features which are in progress and soon will be added to the Buildings AI. These are in different stages of testing. Soon you'll get hands-on to this features. So one is the PDF to BIM. So you just need to upload your floor plan in PDF or JPG format, and then here you can view the floor plan, and here you're fixing the reference. What is the dimension of a wall or something? And then the AI identifies the rooms and partitions and all the design, all the other building elements like walls and windows and things, and it creates the 3D like building information model. So from where you can go to the other steps and so on. So this is one promising feature, and we are testing it out, and soon it will be added. And then another AI feature, which is like AI assistant, building AI assistant, which will be throughout the process. It will be assisting you. You can chat with it. There are LLM models we can select. So whatever is time consuming or manually effort intense things, so you can easily chat with it and ask them. For example, you want to view only the west facing walls for all the floors, and you want to assign for all the walls, you want to assign a different material. So all sort of things you can do on by this with the help of AI assistant. So here you're changing selecting the walls and change the material properties through AI assistant. So without further ado, we'll start seeing the product in action. Swapnil, yeah, I'll
Yes,
hand over the mic to Swapnil.
I'll share my screen for the next session. It will be great if someone can just confirm if you are able to view the slide, case study. A quick thumbs up, or in the chat box you can just.
Yes, I'm seeing a lot of yes in the chat box.
Okay. All right. So firstly, I wanted to convey that this particular software is completely based on browser, and it uses Energy Plus in the back end. But the whole process of setting up the model, importing it, setting up the input loads, everything is through a web browser. So this particular case study is for a high-rise building, a mid-rise building, I would say, of about 6th floor. It's a commercial usage building. And this is an internal case study which we use to demonstrate the workflow and the sort of intelligent database assignment that we have in the tool. So the outline of this particular case study that I'll walk you through in the next slides is basically, first I'll introduce you to the architectural details, then the building AI load inputs that we have used to set up this particular simulation. Next, what is the load output that our software basically presents after the simulation gets completed? Some highlight or glimpse of the strength of the database that we have in terms of materials that you can use for your energy simulations or load calculations, and also the inbuilt HVAC systems, which are sort of present in the library, which you can directly assign to various zones in the model. And lastly, I'll give you a quick walkthrough over the entire workflow of this browser-based tool and how you can start from basically a BIM model and then do the entire load calculation as well as the energy simulations. So we selected this particular case study or building geometry to highlight both the heating and cooling load calculations. In this particular webinar, we'll be focusing only on the load calculation or estimating the loads, not on the energy, energy calculations will come in our next few webinars. So this is a mid-rise office building, and it consists of about six floors. First floor is sort of a completely open lobby type of floor. The location that we use is basically based in New York, 7th Avenue, New York. So it is like it gives a climate zone of 5A, which even is a ideal case for heating as well as cooling load. Both the extreme temperatures and ambient sort of weather conditions are included. The total number of floors are 5, but usage-wise, considering the including the lobby of the first floor, the usage-wise, it's divided into 156 space utilities across the entire building. So it will have office rooms, it will have pantry, it will have restrooms, it will have entire conference rooms or individual seating rooms for different occupants. So it's total number of spaces across the different floors are around 156. The conditions that we have used, the design day condition for this simulation is basically for winter, we have used 12.2 degrees Fahrenheit. And for summer, we have used 97.16 degree Fahrenheit, which is sort of a worst case, near about the worst case worst case day temperatures in different conditions. And for set point for the simulations, for winter, we are using 70 degree Fahrenheit, and for summer we are using 75 degree Fahrenheit, which is fair about closer to the thermal comfort, expected thermal comfort in the commercial or office space type of environment. Now, in this particular simulation, the critical part like our tool has is an inbuilt library of materials. So when you import a geometry, the starting point can be from either a Revit or building JSON file, which is basically built using a third-party tool, or you can also use some of our upcoming features like PDF to BIM model or 3D extraction tools, and you basically get a 3D BIM model into the software. So from that that particular model will have the spaces coming in as well as the envelope entities like internal walls, the glass surfaces or the glass entities, geometries, and it will have the various other divisions in the model. So the first step that our platform basically allows is to quickly assign the materials in the library. There is a huge set of library of materials, and you can just select the entities using either our like a text-based sort of AI agent, or you can even use the UI through mouse, and then you can actually quickly assign materials to all these entities. So this particular geometry has internal exterior walls with material assigned in the inbuilt library having R value of 16.77 in BTU units. Similarly, for interior walls, we are giving a sort of highly insulated type of interior walls, as well as for the roof, we are giving around 16.45. The interior walls we are giving slightly conducting, and for the glass we are using a single pane glass type of near about that type of U value. So it's sort of very closer to a worst case scenario model. Going ahead now, apart from the assigning the materials, we are also assigning the internal heat gains, which consist of multiple components like the power and equipment loads, the lighting loads, the people load, which forms two components, sensible as well as latent loads. And this particular assignment is not manual. It's like a quick way through the inbuilt space types. So depending upon commonly available space types for different commercial or residential use, we have commonly available multiple space types in the library, and you can just select them and apply to the particular space geometry. So this like shown in the screen, we are basically applying a default office space type, which will have all the inbuilt properties which are commonly used in a commercial office type of space. So it will have area per person, which directly defines the occupancy. The tool will also give you inbuilt, pre-built value of sensible load, lighting load, latent heat per person. It will also give you equipment or power load densities, and it will also give inbuilt schedules, which are basically depending upon intelligent database that we have incorporated in the tool based on various usage scenario, like office will be operating during weekdays. Depending upon that, for lighting and occupancy, directly those schedules are assigned for the space type. Now, one thing is this: these are the inbuilt default basically values that are into the space type, but you can also create your own space types by editing this, or starting with a new space type, and you can modify this as required. So after that, a good feature or a quick feature that allows you to basically bypass the energy complex energy calculations and just size up your entire model heat or cooling load, and design the, or just get a quick I would say estimate for the sizing the HVAC system, is a concept called as ideal air load system. So we have apart from the complex HVAC systems available in the library, we have incorporated a concept called as ideal air load systems, which bypasses the entire complex setup of HVAC systems, and you just assign this, which will be like a 100% efficient type of HVAC systems. This will basically give you a quick estimate of the entire heating or the cooling load without going into complexities of the energy calculation. So in this particular case study, we have used that particular ideal air load system for the zones. In the space type that we have used in this simulation include almost about 12 space types. So there is a different based on their usage. There is active storage room type of space type. There is basically office space type, conference room, dining area, the food preparation area. There is also a typical office restroom and a sort of a lobby space type. And all these values, which include the number of occupancy, then the total heat gain, latent heat gain, lighting and equipment load, are pre-built into the simulation. So you just have to select that particular space type, assign it to the space in your basically building model, the geometry, and then all these properties get assigned to that particular space. Now, we saw about the load inputs that we give to the simulation. Now, what are the load outputs that we basically extract from our platform? So there are two types of load outputs. One is for the entire facility, which is the entire building setup, and the other one is for zone wise. So if we see the results of this, the peak heating basically values for the entire facility can be obtained, and you have it into the complete divisions that are available are also displayed in the results. So we have the heating peak load coming in due to the external walls. There is also the heat loads coming in from the roof, internal due to infiltration doors, as well as the zone ventilation required. Due to the zone ventilation, what is the additional heat gains that are there. So all these values, their distribution breakup is available from the tool. And similarly for zone wise, so this is an example of just a single room, which we named as manager room. For that, we have the entire breakup of the heat envelope gains that is available from the tool. And you can also do the same for the cooling load as well. So even for cooling load, you have all those components for zone wise as well as the entire facility. The internal gains, which are of course considered for a calculation of cooling, are prominent when we do the cooling load type of calculations. Now, coming back to the some of the software features, like I highlighted, we have used a set of materials that is available in the library. So we have more than 600 plus materials covering different type of entities like exterior wall, interior wall, windows, roof. The R value are inbuilt in the tool. So you can just, based on the climate zone, based on the typical construction norms, you can just assign this to the entire geometrical model entities that are there. Similarly, HVAC library is available, HVAC systems library is available along with the ideal air systems. If you want to go into complex HVAC setup and actually go into energy calculations or energy simulations, you have even the air handling units, the split air handling units, as well as the plant side systems, and individual zone terminal units are also available, as these are all inbuilt. So you can use these templates quickly and assign them to the zones, or you can also customize and create your own HVAC systems. So I think this was about the case study. I'll just now quickly show you how the platform basically works through the browser using this particular demo. I hope the video is visible. If otherwise, you can just put raise hands in the chat box. So this is how our tool basically, or the platform basically, the start point is. So you can bring in the DWG file through AutoCAD architecture, which is one of the start points. You can also probably retrace or sketch or create a 3D through third-party tool and bring the floor space JSON file into this. Now, this basically is extracted into a 3D BIM and a building energy model with smart defaults into our tool. So, like I said, in the current case study, we showed a mid-rise building. Similarly, you can bring in multiple types of buildings, and the 3D extraction as well as assigning of basically the smart defaults based on the climate zone happens through the tool through few clicks, and the model is set up. The entire building energy model is set up. So this is how the start point right now is shown as an example through AutoCAD architecture platform. There is a plugin for our tool, and then once we use that, the entire 3D geometrical extraction of the BIM model happens in the tool, and you see these different entities as per their creation. So you can just quickly filter, create, assign materials to these different entities by multiple selection, as well as the AI assistant tool that is available. Now, next, the space types that are imported need to be assigned based on their utilities. So there is a whole library of space types which you can assign and just even customize different properties for the space type. And there are pre-built values for each space type that are available in our library. Once that is done, then comes the zones. Different zones have to be given the HVAC systems that are available within the library. So you can either rename or like group zones as required, or then post the zones are basically defined. You can go ahead and select multiple zones, assign either common HVAC systems, or you can go with ideal air systems if you want to do a quick HVAC calculations, quick load, thermal load calculations rather than the energy, full energy calculations. So this is assignment of basically the air side systems. Next, for the same zones, we also have a library of plant side systems which can be assigned, which takes care of the plant side operations. These complex setups are required only if you want to do energy full-fledged energy calculations. For quickly estimating the thermal load, you can just bypass all these steps by just assigning the ideal air load system. Now, once this setup is done, the user has two options: do only the load calculations, thermal load calculations, or do both thermal load and the energy calculations or the energy simulation. So once that is done, there is a in the backend using Energy Plus, we have a very smart or sort of insightful result viewer in the same platform. You don't need to download heavy tabulated files. In the same platform, you see the divisions or the breakdown of the load as well as the energy. There is another smart feature called as Report GPT, like Praveen explained, which is sort of a text-based or a chat-based tool, which can be used to extract zone-wise results, full load summary reports. Also, you can view the result entities in charts or the load breakdown in using this tool, using this chat feature. And you can also import external files to use this as a on top of that to extract the results. And we have a data hub, which is basically a space where you can import or download the existing load calculation files which are written in the backend. You can share multiple versions of your project with multiple users in the organization, and also use this as a viewer if you want to upload any 3D CAD or 2D CAD format files, building related files. You can use this as a viewer as well. So it's like a storage as a view as well as a viewer. So it's a combination of both. So this is what the tool is right now, and we are continuously developing it and making it available for early access for the interested users. I would just like to quickly walk you through how you can basically, before we go with question and session, how you can view all the detailed information of our platform. So this is what our current platform website is. You can go to simulationhub.com and then go to Buildings AI. So the tool name is Buildings AI, and here you can explore the various features of the tool. There are resources which can help you to see the functionalities. You can post that. You can just go and press request demo, which is sort of a way to participate in our early access program. Once you do that, you just to quickly fill some basic information and we'll get back to you. We'll schedule a detailed demo with you, as well as you get access to our tool, which is completely free for initial few months to try it out. And there are various ways in which we can collaborate on any of your requirement. Now, apart from this, basic straightforward way to use this off-the-shelf product, there are other areas also which we are basically exploring. If you have any requirements of customizing this tool, so basically talking in a simple ways, this is a very intelligent and smart platform using agentic AI, which is just a workflow based on browser, and it is based on Energy Plus. So if you have any in-house requirement where you want to deploy this customized or a derivative version of this product, we are also open to those enterprise level collaborations. We are also open to basically if you come from manufacturing in terms of HVAC equipments or components, as well as construction materials. So we are open to incorporating your specific product specs into our tool, into our library of materials, into our library of HVAC systems. We are also trying to come up with a HVAC sort of configurator, which is a smart canvas based HVAC configurator. And if you have any complex HVAC systems which you use regularly in your projects, we can also deploy those templates in the backend and make a enterprise ready version of this product for you. So all these avenues of basically using a very smart workflow on top of Energy Plus through a web browser are open, and you can contact us for any of your requirements and we'll certainly get back to you. So this is what I had from the application side or the case study of a simple mid-rise building. I'll basically hand over to Praveen, who will guide you through next session's Q&A type of interaction. Thank you.
Yes, thanks, Swapnil, for that walkthrough and case study. So we got a few, interesting questions. We'll take it together. So this is from Nilesh. He has a question of which heat load calculation method is adapted in the background. Swapnil, you would like to take that? Okay, so maybe I'll answer that. So we are using Energy Plus engine in the backend, which is developed by Department of Energy, and the method which we use for heat load calculation is heat balance method. So which is the most accurate in the complex things. So yeah, so that is being used in the backend. And there is another, is this tool released or beta version? So as Swapnil mentioned, right now it is at the early access stage, where you can apply or request for that early access. We'll set up a call, discuss, and then provide the access to the software. So we launched this software at the AHR Expo in Orlando, and as well as IBPSA biannual meeting. So there, so now it is still, there are a lot of developments going on, but there are set of features that has been developed and it's in usable condition, so that you can have a access to this. So the next one is, what are all the space types that you have? This is from Fred. Fred, we have quite kind of 16 plus categories of building types, and then around 150 plus space type templates available in the app. So you can, it will cover most of almost everything available. Yeah. So another question from Fred. Yes, will you make this recording available later? Yes, this recording will be available on our website, and we'll email you the link, or later you can come back and check out the webinar section. You'll be able to access the recording. Okay, it's similar question from Darshan. I guess the software demo. Yes, it is available on YouTube and on our webpage as well. Like you can right now you can see the product demo video on the page. So how much time, this is from Sankar, how much time it takes to run load and energy calculation, for example, 50,000 square feet building, different types of zones. So it will be appropriate to answer this based on the number of zones. So let's say take a typical office space with 100 zones approximately, it takes 5 to 7 minutes, and large mixed use kind of building with 300 zones, then it takes 10 to 12 minutes. So that is a runtime right now. That is a solve runtime. Okay. And okay, there is few more question. Are the design data from ASHRAE? Yes, those data are taken from ASHRAE 90.1, the material construction assembly sets and the material properties, and based on the space types, like all the occupant schedules per square feet and all those data. Yeah.
So those are the pre-built data, which sort of based on the space type and even has some component of basically the climate zone. But of course, I mean, you can even edit and make, like, if there is a standard room or a conference room type of space type, you can even edit those, and each and every component of those can be edited and you can use them further.
Okay. Fine. Is this like tool mainly for commercial, residential, and industrial, like all these things? That is one question. Yes, Swapnil, what are your like?
So technically, I mean, this is for multiple floors commercial, because the complexities of space types are more in commercial. But fundamentally, if you have the geometry type imported and the space types are also typically matching your residential application, we can tweak the space type to suit your residential application as well. But all the design of the space types, I would say, is more of, or even the HVC systems is more of from a commercial usage point of view.
Okay, one connected question from Mahan Das. So can we use this tool for hospitals and clean rooms? I suppose that's a yes, right? Like that's
yes, for yeah, I mean, you
covered.
can use it for hospitals and clean room as well.
Right.
The only thing, the specialized medical equipment type of I think space types would be you need to customize those based on specs that are available for those equipment. So you will need to tweak some of the space types to adjust them to the heat gains related to medical equipments, particularly.
Okay, okay. Thanks. And another question is like, is this tool only for HVAC or we can use it for plumbing and firefighting? Yeah, right now it's HVAC and energy modeling. And in the later future, we are targeting daylight, climate analysis, so more of whole building performance. So already we have a CFD module incorporated to analyze the thermal comfort and indoor air quality kind of things. So we'll expand more, but not on the plumbing and firefighting. Yeah. Okay. So few more questions are there. How are the weather data and the design days handled? So this is from the TMY EPW files, TMY3 typical meteorological year, and it is selected based on the nearest weather data available to the site location, and from where the ASHRAE design days and these things are fetched.
So it's basically taken from a weather file, and based on the weather file, the worst case summer or winter based on the climate zone is selected as a design day. And there is an option, I guess, to I need to check, go back and check, but there is an option to even for ideal air systems to set this manually, but I need to check that.
Okay. Thanks, Swapnil. I guess there are a few more questions, but we are running out of time. What we'll do is we'll connect with them through emails, and later we can answer those queries. Or you can reach out to us. You can request a demo. We'll connect over a call, and we can discuss in detail. So yes, so that's the thanks everyone for joining and stay till the end of the session. Have a wonderful day or a good night. Thanks for joining.